Now in part C, we're asked to write down the value of the lower quartile, Q1. And this is obvious because you should be able to see that we worked out earlier that the upper quartile, Q3, was 35.4. So Q1 has got to be exactly the same distance away from the 30 as the 35.4 is, but below it because of the symmetry of the distribution. So if we were to work out this width here, it's clearly going to be 35.4 minus 30, which is a width of 5.4 units. Let's just mark that in there, 5.4. So we've got to go 5.4 units back in this direction to get to Q1. So for Q1 then, Q1 is going to equal 30 minus 5.4. And if you do that, you're going to get 24.6. Okay, so we've got the value of Q1 then 24.6. We've got the value of Q3 as being 35.4. And in part D, they ask us to work out two outliers. We've got this outlier, H, and this outlier K, and it's defined by these two equations here. So we've got to work them out, and that's going to be very simple now because all we need to do is substitute our values in that we found. Q1 then is 24.6 minus 1.5 multiplied by Q3 minus Q1. Q3 minus Q1, by the way, is called the interquartile range. And if you were to do that, 35.4 minus 24.6, we'll put it in anyway, 35.4 minus 24.6. You can see it's going to be 10.4, that width there, 10.4. Anyway, work that out, and what you should find you get is 8.4. So anything below 8.4 is going to be an outlier, an extreme value if you like. And K is the values of outliers over this side. So we can work that out by putting our values in for Q3. Q3 was 35.4, and then we got plus 1.5 times the interquartile range, which is going to be again 35.4 minus 24.6, a value of 10.4. Work that one out and you'll find you get 51.6. Okay? So there are two outliers, and we're going to be using these in the next part of the question.